Hello everyone. In this video, we're going to be learning how to solve this problem on the board. Now, this is a question under the magnetic field. We have a charge Q equals to 40 microcoulombs, moves with instantaneous velocity U, which is equals to 5 times 10 raised to the fourth J meters per second through the uniform fields. So we are given the electric field vector, okay, which this is the electric field vector, this is the magnetic field vector, okay. Now we want to obtain the magnitude and direction of the charge on, or of the force on charge Q, okay. We want to obtain the magnitude and direction of the force on charge Q. All right. Now, when we have a charge, okay, existing in the region of both electric and magnetic field, now, the electric charge will experience a force which can be given as a vector sum of the magnetic force and the what? Electric force on the charge. Okay, so which means when we have both electric and magnetic field present in a region, okay, the force on a unit positive test charge, okay, which exists in that region will be equals to the vector sum of the electric force, okay, and the magnetic force. And that equation is what we call the Lorentz equation. All right. So now the solution to this problem would not be, so now let's use the Lorentz equation. Now, according to the Lorentz equation, now we have that the resultant force, the magnitude of the resultant force or the resultant force, okay, will be equals to the magnetic force plus the electric force, or we can also have it as electric force plus the magnetic force. Now we know that electric force is QE. That is the product of electric charge and what? Electric and the electric field vector. Okay. Then the magnetic force on the charge would be QUB. Okay, where B is the what? Is the magnetic field vector, which is a magnetic flux density. So we have QUB. Okay, so when we add these two forces, okay, we're going to have our Lorentz equation to be, okay, we have QE, then we also have QUB, okay, so that F will be equals to Q into E, okay, which is the electric field vector, then UB. So with this equation, we'll be able to find out the what? We'll be able to find out the vector force on the charge. Then when we know the vector force on the charge, then we can now calculate the magnitude of the force on the charge. All right. So now we know that to calculate the vector force on the charge, the vector force on the charge, which is the Lorentz equation, using the Lorentz equation, will be the magnitude of the charge, which is 40 microcoulombs. And we know that 1 microcoulombs is the same as what? 10 raised to the power of -6 coulombs. So we have 10 raised to the power of, so 40 multiplied by 10 raised to the power of -6. Now open parentheses. So remember, we have the electric field vector. Now the electric field vector is given to be 6 multiplied by 10 raised to the fourth, okay, parentheses 0.52i, which is the unit vector in the x direction, then plus 0.56j, okay, which is the unit vector in the y direction. And also we have 0.64k, and this is which is the unit vector in the z direction. Then plus, now we're also giving the what? The magnitude, we are also giving the magnetic field vector, okay? But don't forget, we also have u, which is the what? Instantaneous velocity. So the instantaneous velocity is 5 times 10 raised to the power of 4j, which is the unit vector in the y direction. So I'm going to use that to multiply we're going to use that to multiply the what? The magnetic field vector. And we have our magnetic field vector to be 1.7 multiplied by 0.693i, okay, plus 0.6j, okay, plus 0.4k, okay. Then we close the parenthesis. All right, so this is the vector force. All right, this is the vector force. All right, now we know that force is a vector quantity. All right, so in this case, we now have, now what is 40 40 times 10 raised to the negative 6, okay, 40 times 10 raised to the negative 6 multiplied by 60,000, which is 6 times 10 raised to the power of 4. All right, so that will be 0.24. Okay, we have 0.2, that will be 2.4. All right, so that will be 2.4. That is, when we distribute 40 times 10 raised to the negative 6, in this case, okay, that is when we multiply by 6 multiplied by 10 raised to the 4th, it will be 2.4. Then we then have multiplied by 0.521, 0.5256j, then plus 0.64k, okay, then plus, now we're also going to multiply 5 times 10 raised to the 4th. We multiply by 40 times 10 raised to the negative 6, okay, power. Then we also have 1.7. So now, so what is 1.7 multiplied by 0.0004? Because 40 multiplied by 10 raised to the power of minus 6 will be 0.00004. Okay, now we multiply by 50,000, which is 5 times 10 raised to the power of 4. Okay, and that would be 3.4. So which means we're going to have 3.4j. Okay, so we then have 3.4j, which we now multiply 0.693i plus 0.6j plus 0.4k. All right, now, so in this case, we have to distribute 2.4. So let's expand. So what is 2.4 multiplied by 0.5252? That'll be 1.248. So we have 1.248i. Okay. Then again, we have 2.4 multiplied by 0.56. Okay. That'll be 1.344j. Then we also multiply 0.64 by 2.4. Okay, that will be 1.536k. We have 1.536k. Okay, now, then plus what we have here is 3.4j. Okay, now when we multiply 3.4j by 0.693i, now we need to understand that when it comes to cross product of vectors, when we have I times I, okay, the cross product of I and I will be what? 0. Cross product of j and j, that's j times j, that will be what? 0. Okay, then when we have I times j, okay, that will be k. When we have I times k, that will be what? J. Then when we have j times k, that will be what? I. But when we have j times I, that will be what? Negative k. Okay, these are the key terms. So in this case, so when we have 3.4j multiplied by 0.693, 3.4 multiplied by 0.693, okay, that will be 2.356. Okay, so we know that j times I is negative k. So we have negative 2.356. Okay, and that will be what? K. Okay, now also when we multiply 3.4j by 0.6j, that will be 0 because we know that j times j is what? 0. Then when we multiply 3.4j by 0.4k, we know that j times k is what? I. So we then have 3.4, okay, multiplied by 0.4, and that will be 1.36 1.36i 1.36i 1.36i. Okay, now so we're going to what combine like terms in this case. So when we add 1.36 to 1.248, okay, that would be 2, okay, that would be 2.61 I, okay. Then we also have positive, that's plus 1.344 J. Then here we have 1.536K, okay. What is 1.536 minus 2.356? Okay, 1.536 minus 2.356. All right, so that will be negative 0.82K. That'll be minus 0.82K. So this is the vector, okay? This is the resultant vector, okay? You know, I said it is called the vector force, okay? Now we want to obtain the magnitude of the force. So to obtain the magnitude of the force, now magnitude of F, now magnitude of F, okay? Magnitude of F of the vector force, okay, that will be the magnitude, okay, the magnitude will be the same thing as the modulus, so it's going to be the what, the positive square root of 2.61, okay, 2.61 to the square, then 1.34 to the square, okay, then also plus negative 0.82 to the square, okay. So now let's find out 2.61 to the square plus 1.34 to the square, then plus 0.82 to the square. When we add all of that together, so we're going to have the magnitude of F to be the square root of 9.280, okay, 801, okay. Now let's get the square root of 9.2801. Now the square root of 9.2801, that will be, so the magnitude of F, the magnitude of force F, that will be 3.046, and that will be F equals to 3.05 Newton. That will be 3.05 Newton. So this is the magnitude of the force on the what? On the charge Q. That's the magnitude of the force on the charge Q. Okay, now we also want to what? We also want to find the direction of the force on charge Q. So we are going to use what we call the direction of cosine. Okay, so the direction of F. Okay, that means that we use the direction cosine. So which means now what we have here, remember we have, this is more like having xi plus yj plus zk, like that. Okay, now so in this case, in the now when we talk about now the direction of cosine in the x direction, okay, would be this value divided by, so let's say in the x direction, okay, so we have in the x direction, let's say we have that to be L, so that will be 2.61 divided by 3.05, okay, that's in the x direction. Now in the y direction, okay, let's say that's what, M, okay, in the y direction it's going to be 1.344 out of 3.05, okay. So what is 2.61? Okay, what is 2.61 divided by 3.05? Okay, that would be 0.86. So in the x direction, that would be 0.86. Okay, we have 0.86. Now in the now remember, we can actually obtain the angle in this case. What angle this would be? Okay, direction of cosine, don't forget. Then what is our 1.344 344 divided by 3.05. Okay, that would be 0.441. So this will be equals to 0.441. Okay, now let's in the z direction. Okay, in the direction of z. Okay, so we have that will be, we're going to divide this value. This is the unit vector in the z direction. So that'll be negative, that'll be minus 0.82 divided by 3.05, and that will give us minus 0.269. Okay, we have minus 0.82 divided by 3.05, and that will be minus 0.269, minus 0.269. So the direction. Okay, so like I said, this is the magnitude of the force on the charge, and then the direction. Okay, the direction of the force on the charge. Okay, we have the first one in the x direction, which is 0.86. Okay, that's when we divide the what? When we divide 2.61, okay, by this value, okay, we get the magnitude, we get the direction, okay, along x-axis. Then in the y direction, so I represent that using letter what? N, and we have this value 1.344 divided by 3.05, and that will be 0.441. Okay, now in the z direction, we have n to be equals to, it will be now this value negative 0.82 divided by 3.05, and that will be negative 0.269, and that is the direction of f. All right, that is direction of f. Thank you.